This RxJS-driven approach has some issues, as I outlined. To be precise, you could still have an app where state can be updated from anywhere because you maybe failed to set up a clear flow of data. Your state might also possibly be mutable, which means that whilst you might have only a couple of places where your state is intended to change, your code in there might not force you to state the old data by overriding it with new data. And that is what I would recommend doing though, because otherwise Angular sometimes doesn't pick up some changes to your state because of the reference type nature of objects and arrays in JavaScript, where if you only change a property of an object, the overall object didn't change, and therefore such a state change might not get picked up. And in addition, handling side effects, and that means things like HTTP requests, it's unclear where this should happen. Should you write the code for sending them in a component? Should you do it in a service? And yes, all these problems can of course be solved, and you can have a clear route and a clear approach regarding all these things. But especially if you're working on a bigger app with a bigger team, it can be hard to enforce the best practices across all team members here. And therefore, enforcing a specific pattern might be hard because Angular by default doesn't enforce one. And that is where NgRx may help you, or to be precise, Redux may help you. Now, what is Redux? I just introduced NgRx. What is Redux? Well, if you have a React.js background, you might already know Redux. Otherwise, you will learn about it now. Redux is a state management pattern. It's also a library that helps you implement that pattern into any application. The idea behind Redux, so behind that approach for managing state, and always keep in mind, state is just data or information in your app. So the idea behind managing that state with Redux is that you have one central store in your entire application that holds your application state. So think of that as a large JavaScript object that contains all the data the different parts of your application need. Of course, kind of categorized in properties that might then hold nested objects. But in the end, that's the idea. Have one large data store. Your different parts of the application, services and components, can still interact with each other, but they receive their state from that store. So that store is the single source of truth that manages the entire application state. Now, of course, state is not just received. You sometimes also need to change the state. For example, when you add a new recipe. And for that, in the Redux world, you dispatch so-called actions. An action is in the end also just a JavaScript object with an identifier, basically identifying the kind of action you want to perform, and optionally a payload. So if that action needs some extra data to complete, for example, if you're creating a new recipe, you would need to attach that recipe data to the action, then you can have that data in the action that is supported by Redux. Now that action doesn't directly reach the store, instead it reaches a so-called reducer. Now a reducer is just a function, a JavaScript function that gets the current state, which is stored in the store, and the action as an input, passed in automatically by the Redux library if you use that. And then in the reducer, you can have a look at the action identifier, find out which kind of action it is, for example, add a recipe or delete a recipe, and then perform code on the state which you also got as an argument to update that state, however, in an immutable way. So by copying it and then changing the copy. Because ultimately, the reducer returns a new state. So it returns a copy of the old state that will have been changed according to the action. And that state, which is returned by the reducer, then is forwarded to the application store, where this reduced state, again, the state was edited immutably, so without touching the old state, instead copying it and then editing the copy. So where this reduced state is then overwriting the old state of the application. That is the Redux pattern. And as you can see, it enforces a pretty clean and clear flow of data. We only have one place in the app where we store our data, and we only edit it through actions and reducers, and we receive the state through so-called subscriptions, which we can set up. Now, if you're using Angular, you could also use the Redux library. It's not restricted to be used with React.js only. But NgRx is, in the end, just Angular's implementation of Redux. Now it comes with some differences or Angular specific things. For example, the left orange box here, it's deeply integrated into Angular. So it, for example, comes with injectable services so that you can easily access your application store in any part of your app by simply injecting it. It also embraces RxJS and observables. So all the state is managed as one large observable, you could say, and that also can yield certain advantages. For example, you can use all the observable operators to then edit the state you're fetching in the component where you need it, in the way you need it there. This will not change the store state, of course. And it, of course, also supports TypeScript. Now, in addition, there is one extra part of that state management library, which is about side effects. So NgRx also gives you a tool that makes working with side effects easier. And side effects, just to bring that back in memory, are things like sending HTTP requests. NgRx also helps with that. Traditionally in Redux, that was kind of an open question. It was unclear where you should send such side effects, where you should send such HTTP requests. So typically asynchronous code was always a problem because reducers, I can say that already, only may execute synchronous code. So you must not and you can't send HTTP requests from inside a reducer function, for example. And therefore it always was kind of an open question in Redux where you should do such asynchronous tasks. NgRx ships with a built-in solution, and you will learn about that solution here too. So that was lots of theory. Time to finally get back to the code and start implementing that pattern and that package there step by step.